Welcome back to Technogate. Today we'll discuss about the topic locus. In analytical geometry, this is the first topic. So basically, if I'm having a point, if I'm having in the Cartesian plane, in locus, we are having different types of curves like straight lines, circles, and all the things. If I want to, before drawing any curves, first we need to locate the particular point position, right? So in order to know the locus of any particular curve, if I say it is straight line, a circle, or parabola, ellipse, hyperbola, whatever it may be the curve, if I need to draw that particular curve in the Cartesian plane, so we need to start with some point, right? So if we have been given some point, if I need to find out the locus of that particular point, or what was the position, exact position of my particular point on a Cartesian plane, it is actually given by locus. So let us try to take the definition of this particular thing here. So that was the set of points, the set of points, the set of points that satisfy the given given geometric consistent geometric conditions. Consistent geometric conditions is known as locus. So the set of points that satisfy the given consistent geometric conditions is known as locus. So if we have been given some conditions, so if you are having a set of points that is going to satisfy that particular point satisfying my given geometric conditions. Let us suppose the center is the distance from one point to other point is definitely equivalent to the distance from the other point. If I take a circle equation, the distance from center to any point on the circle is definitely equal to the center distance from center to any other point on the circle. The distance is actually equal, right? That we can call it as a radius. So if you are having such type of geometric conditions, if you are having some points, if that point is satisfying that particular conditions, we are actually calling it as a locus. So let us see some of the important parameters in it. The first thing is, try to write down everybody the point, the point, the point P x comma y is called the ordered pair. That we know, if we have been given some points, that point is definitely consisting of x comma y, and we are usually calling it as an ordered pair. In that one, the first element of ordered pair. So in this particular point ordered pair, the first element is called is called x coordinate. So we usually having these kind of terminology only. X coordinate, we are also calling it as an abscissa. We usually know out of the maths, we are calling this kind of terminology as a x coordinate and y coordinate. But whereas in case of maths terminology, we are calling it as a second element. We are calling it as an ordinate. Abscissa is called as y coordinate. Y coordinate, and it is also called as the ordinate. It is also called as the ordinate. The x quadrant we are calling it as an abscissa, y quadrant we are calling it as an ordinate. Right? So if P lies on the line segment, line segment joining line segment joining A and B, then P divide AB internally in the ratio of internally in the ratio in the ratio in the ratio AP is to PB. So let us try to draw the representation of this particular thing. If I'm having a line here, that was A and B. If P lies on the line segment joining AB, then P divide AB internally in the ratio of AP is to PB. That means if I'm having a point here, let us suppose it is my point P. If my particular point is dividing my line segment AP east PB, that means if you are taking a point in the middle of the line, if it is dividing my particular line in the ratio of AP east PB, the whole line got divided into two parts, right? So this particular ratio is AP and we are having PB. As we are having the 2 points here, it is actually divided in the ratio of AP east PB. As we are dividing it internally, this we can call it as an internal ratio, that is AP is to PB. Okay, and let us take the other thing here. If P lies, if P lies outside the line, the same point P, if it is cut, if it is lies outside the line AB, outside the line AB, then P is said to divide AB. P is said to divide AB. AB means that is the line externally in the ratio. Externally in the ratio. The same thing that was AP is to PB. Right? So if my particular point, if it is located at the middle of the line segment AB, it is actually dividing that line segment AP is to PB internally in the ratio. But if you are having the same point outside the line, let us suppose it if it is my line segment that was A and B, and we are having one more point that is P, it is actually making some ratio of this particular line. And as we are taking outside of my particular line that is AB, as we are taking outside of the line, it is actually divide the line in the ratio AP is to PB, the same ratio in the previous case, but it is externally it is making the ratio that was AP is to PB, AP is to PB. All right. So based on the location of the point, if you are taking inside of the line segment, it is actually cutting internally in the ratio of AP is to PB. Whereas in case of if you are having a point outside of the line, so that it is also making the same ratio, but it is externally. Okay. So these are the 2 points that we need to remember if we are taking any point in middle of the line segment. And let us take one more point here, that was the point which divides a line segment. The point which divides a line segment, which divides a line segment in the ratio, it may be internally or externally. 1 is to 2 or 2 is to 1. 2 is to 1 are called the point of trisection. Are called the point of trisection. As we have seen before the 2 points, if we are taken one point here in between my line segment AB, either it may be internally or externally. But if it is having some particular ratio of 1 is to 2 or 2 is to 1, that means this particular portion is 1 and the second portion is 1 is to 2. If it is dividing in this ratio 1 is to 2 or 2 is to 1, the total portion we are calling it as a point of trisection, as 1 plus 2 or 2 plus 1 is equivalent to 3. Here it is having the point of trisection. Point of trisection we are having. If it is having this particular ratio of 1 is to 2 or 2 is to 1, we are calling it as a point of trisection. Okay, so these are the points if you are having a line segment and if it is cutting any line in the middle of the line segment or taking a point outside of the line, it is going to cut in the particular ratios. If it is following this particular ratio, we are calling it as a point of trisection. And let me give you one more thing here. That was the distance between the 2 points. The distance between the 2 points. Let us suppose I'm taking the 2 points here. One is p x1 comma y1, and the next point is q x2 comma y2. If the 2 points were given like this, these two lines are different. These 2 points are completely different. Is given by, if I want to find out the particular distance between these two lines, this is formula is very important. For further chapters also, this is going to be very helpful. If I want to find out the distance between these two particular lines, we usually having a formula that is distance between two formula is given by the difference of the 2 points, that was x2 minus x1 whole square plus y2 minus y1 whole square. As we have been given the 2 points can be anything. Okay. And the next thing will be the distance of point P x1 comma y1 from the origin, from the origin 0 comma, I'm taking it as an O. The point is also 0 comma 0, right? So this the above formula is also going to apply for this particular case, as I'm having one point at this particular point and the second point is at a origin. If I want to find out the distance between these two things, we also we also able to follow this particular thing. Let us try to take the same formula, that was x2 minus x1 whole square or y2 minus y1 whole square. If we take any point as the first point, it was 0 minus x1 whole square, and we are having 0 minus y1 whole square. So as we are having the square here, and if you are having a negative and if you are having an even number to the negative, so we are actually getting as a positive, right? X1 square plus y1 square. Okay, so this is the particular thing. And the next thing will be the distance between 2 points, the distance between 2 points. Let us suppose 2 points. So observe the points location. It was A x1 comma 0 and B is x2 comma 0. That means x2 comma 0 is. So here is my distance will be, I'm taking 2 points here. If we observe the points carefully, we are having the 2 points on completely x-axis because y quadrant is completely absent here, right? If I need to find out the distance between these two particular things, so as we are having only the x quadrant, I'm taking the same formula, that was x2 minus x1 whole square, and y points are completely absent, right? That was 0 minus 0 whole square. It is equivalent to under root of x2 minus x1 whole square. If the square root is becoming cancelled, we are actually getting is modulus of x2 minus x1. So the magnitude is always positive, and we know that the distances and angles are never be negative. It is always measured in positive itself. That's why I have taken, if I take x1 minus x2, if I take A point as first point or B point as second point, we are getting the same distance. If we are taking in a reciprocate manner also, we are getting the same distance. Means the distance can never be negative, and angle between the two any objects or also can never be negative. That's why we need to mention the modulus for these particular cases. And the next thing will be the distance between 2 points. What are my 2 points is C 0 comma y1. Next thing will be T 0 comma y2. So the same case reciprocated to that, as we are having the completely y coordinate, that means ordinate points we are having. So that was 0 minus 0 whole square, and we are having y2 minus y1 whole square. It is equivalent to root of y2 minus y1 whole square. If the both the things will be cancelled, and we are taking it as modulus of y2 minus y1. Okay. And the next thing will be the coordinate of a point. The coordinate of a point of a point P which divides the line segment joining a x1 comma y1 and b is x2 comma y2. Okay, x2 comma y2 in the ratio m is to n internally is. So as we have discussed about this topic, if you are having a point, we are dividing that particular point. If you are dividing the line segment by using a point p internally in the ratio that we have discussed this point, right? If we have taken a point p inside of the line segment, if it is cutting my line segment in the ratio of ap is to pb internally, so that ratio it is actually measured by m is to n internally. So for that particular thing, if I want to find out the location of the middle point, we are having a formula that was mx2 plus nx1 by m plus n, and we are having my2 plus ny1 by m plus n. If I want to find out the point, the location of that particular point, which is dividing internally in the ratio m is to n, this is the particular point to find out the location of that particular point. And the same thing can be applied in the next case. But as we are having the ratio outside of the line segment, the coordinates of a point, the coordinate of a point P which divides the line segment joining the points a x1 comma y1 and the next point is b x2 comma y2, right? In the ratio m is to n externally. I'm sorry, this is ratio, right? M is to n externally. Externally is the point P is mx2 minus nx1 by m minus n, my2 minus n by 1 by m minus n. Okay, so this is the location of the particular point. So let us see once again. If I want to find out the location of any particular points, if I want to find out the distance between two things, we are actually calling it as a locus. If you are having point internally, externally, if you are having the particular ratio distance between 2 points, and if you are having the particular x points and y points, if I want to know the location of that particular point internally cutting the line segment AP is to M is to N externally. So these are the particular location of my points. Okay, so thank you for this session. We'll continue some more things in the next classes. Thank you so much.